Welcome to SRR Strategic Intelligence. Every day, automotive service organizations manage thousands of customer appointments, hundreds or even thousands of technicians, large inventories of parts, and countless operational decisions. Keeping all of those moving pieces aligned is a challenging task, especially when customer behavior introduces uncertainty into the scheduling process. One of the most common forms of operational disruption occurs when customers reschedule appointments before service is performed. While a single reschedule may seem insignificant, thousands of reschedules across a large enterprise can create substantial scheduling volatility, reduce technician utilization, increase operational costs, and negatively impact the customer experience. In this video, we will explore how AI, Python, and predictive analytics can help organizations estimate the likelihood that a customer will reschedule an appointment before disruption occurs. We will examine the business problem, the data, the modeling process, the role of AI, and the operational actions organizations can take once predictions become available. By the end of this video, you will understand not only how predictive analytics works, but also how it can create measurable business value through better decisions, improved planning, and more efficient operations. Let's get started. Section 1. The hidden cost of appointment reschedules. Every week, a national automotive repair network manages more than 50,000 appointments across 1,000 service centers. On the surface, the schedule appears full, balanced, and productive. Technicians are assigned, service bays are reserved, parts are ordered, and customers are expecting service. However, reality is often much more complicated. Thousands of appointments may be rescheduled before they occur. Some customers encounter scheduling conflicts. Others face transportation issues, weather concerns, work obligations, family emergencies, or changing priorities. Regardless of the reason, every reschedule introduces uncertainty into the operation. When an appointment moves unexpectedly, technician schedules may become less efficient. Service bays may remain underutilized. Parts planning may become less accurate. Managers may spend additional time adjusting schedules instead of focusing on customer service and operational improvement. At enterprise scale, these seemingly small disruptions accumulate quickly. Lost productivity, increased scheduling complexity, reduced customer satisfaction, and missed revenue opportunities can all result from appointment volatility. This raises an important question. What if organizations could identify which appointments are most likely to move before the customer ever calls? Section 2. Why executives care. Appointment reschedules are not simply scheduling inconveniences. They have implications across the entire organization. From an operational perspective, reschedules affect technician utilization and workforce productivity. From a financial perspective, they impact revenue forecasting and profitability. From a customer perspective, they can contribute to frustration and a less predictable service experience. Executives care because uncertainty creates inefficiency. When appointment schedules become unpredictable, staffing decisions become more difficult. Capacity planning becomes less reliable. Forecasting accuracy declines. Service centers may experience both underutilization and overutilization, depending on how disruptions occur. In large organizations, even small improvements in predictability can generate significant business value. Better forecasts enable better staffing decisions. Better staffing decisions improve productivity. Improved productivity can enhance customer experience and financial performance simultaneously. For leadership teams, reducing uncertainty is often just as valuable as improving efficiency. Predictive analytics helps accomplish both objectives by providing visibility into future risk before operational disruption occurs. Section 3. The question we want to answer. Our objective is straightforward. Before an appointment occurs, can we estimate the probability that the customer will reschedule? Notice that we are not asking whether we can predict the future with certainty. We are asking whether we can estimate risk. If we can identify appointments with elevated reschedule risks several days before the scheduled service date, managers gain valuable time to act. They can reach out to customers, confirm appointments, adjust schedules, prepare contingency plans, or allocate resources more effectively. The goal is not prediction for prediction's sake. The goal is action. Instead of reacting after disruption occurs, we want to identify risk early enough to influence outcomes. The earlier risk becomes visible, the more options organizations have available to manage it. This shift from reactive management to proactive management is one of the primary reasons predictive analytics has become such an important capability across modern organizations. Section 4. Predicting customer behavior before it happens. Organizations predict customer behavior every day. Banks predict loan defaults. Retailers predict customer churn. Insurance companies predict claims. Healthcare organizations predict patient outcomes. Telecommunications providers predict service cancellations. Automotive service organizations can predict appointment reschedules. Although the business problems differ, the underlying principle remains the same. Historical behavior often contains patterns that help explain future behavior. Customers who have frequently rescheduled appointments in the past may be more likely to reschedule again. Certain appointment types may experience higher volatility than others. Weather conditions, appointment lead times, reminder engagement, and customer history may all influence outcomes. Importantly, prediction does not mean certainty. The objective is not to declare what will happen. The objective is to estimate what is more likely to happen. Organizations use probability estimates to prioritize attention, allocate resources, and make more informed decisions. The value comes not from perfect predictions, but from consistently making better decisions than would otherwise be possible. Section 5. What is predictive analytics? Predictive analytics uses historical data to estimate future outcomes. The process begins with collecting and analyzing past information. We examine patterns, relationships, trends, and behaviors that occurred previously. Statistical and machine learning models then learn from those historical observations. Once trained, these models can estimate the likelihood of future events. In our automotive service example, we are interested in estimating the probability that an upcoming appointment will be rescheduled. Predictive analytics differs from traditional reporting because it focuses on the future rather than the past. Traditional analytics might tell us that 12% of appointments were rescheduled last month. Predictive analytics attempts to identify which appointments are most likely to be rescheduled next week. This forward-looking perspective enables organizations to move beyond understanding what happened and begin influencing what happens next. That capability is what makes predictive analytics so valuable in operational environments. Section 6. Prediction and probability. Prediction is often misunderstood. Many people assume that predictive models are attempting to forecast the future with complete certainty. In reality, predictive models estimate probabilities. An appointment with an 80% reschedule probability is not guaranteed to move. Likewise, an appointment with a 10% probability is not guaranteed to remain scheduled. Probability simply reflects relative risk. An 80% probability suggests substantially higher risk than a 10% probability. That information helps organizations prioritize resources and attention. Consider two customers. One has a predicted reschedule probability of 12%. Another has a predicted probability of 81%. Even though either customer could ultimately reschedule, the second customer clearly deserves more attention from an operational standpoint. Probability estimates allow organizations to focus on the appointments most likely to create disruption while avoiding unnecessary effort on lower-risk cases. In many ways, probability is the language of uncertainty. Predictive analytics helps translate uncertainty into actionable information. Section 7. Why organizations build predictive models. Organizations build predictive models because they support better decisions. Without predictive analytics, managers often rely on intuition, experience, or reactive responses after problems occur. Predictive models provide a systematic, data-driven way to anticipate future events. Instead of waiting for disruptions to occur, organizations can estimate risk in advance and prepare accordingly. This can improve resource allocation, increase planning accuracy, reduce operational surprises, and improve overall efficiency. Predictive models also help organizations scale expertise. Rather than relying solely on individual judgment, organizations can apply consistent decision support across thousands of appointments, hundreds of locations, and millions of customer interactions. In our automotive service example, predictive models enable managers to identify high-risk appointments before disruption occurs, allowing them to intervene proactively. Ultimately, predictive analytics helps organizations make better decisions with the information available today, rather than waiting for tomorrow's problems to arrive. Section 8. Our enterprise example. Throughout this video, we will use a national automotive repair organization as our example. This organization operates approximately 1,000 service centers across the country and manages more than 50,000 appointments every week. At this scale, even a small percentage of appointment changes can create substantial operational challenges. Leadership wants to identify customers most likely to reschedule before the appointment date arrives. Their objectives are straightforward: improve technician utilization, reduce scheduling disruption, improve service center efficiency, increase profitability, enhance customer experience. Rather than reacting to appointment changes after they occur, leadership wants a proactive system capable of identifying elevated risk in advance. This example reflects the type of business challenge that predictive analytics is designed to solve. Section 9. What data might we need? Predictive models require data. The quality and relevance of that data often determine the quality of the resulting predictions. Potential variables might include vehicle age, vehicle mileage, appointment lead time, service type, customer loyalty status, reminder engagement history, previous reschedules, prior no-shows, weather conditions, and local traffic conditions. Some variables describe the customer, others describe the vehicle, others describe the appointment itself. Still others capture environmental conditions that may influence behavior. Each variable contributes a small piece of information about the likelihood of future outcomes. Individually, a single variable may provide limited predictive power. Collectively, however, dozens of variables can reveal meaningful patterns that help estimate reschedule risk. The objective is not to collect as much data as possible. The objective is to collect the right data that helps explain customer behavior. Section 10. Target variable, rescheduled_YN. Every predictive model requires a target variable. The target variable represents the outcome we want the model to learn and predict. In our example, the target variable is rescheduled_YN. Historical appointments either remained scheduled or were rescheduled. These historical outcomes provide the examples from which the model learns. When the model examines past appointments, it evaluates the characteristics associated with each outcome. Over time, it learns which patterns tend to precede reschedules and which patterns tend to precede successfully completed appointments. Once training is complete, the model can estimate the probability that a future appointment will belong to one of those outcomes. In simple terms, the target variable defines the question we want the model to answer. Also, for our project, that question is straightforward. Will this appointment remain scheduled, or is it at elevated risk of being rescheduled? Section 11. AI as a business consultant. Before writing a single line of Python, AI can help define the business problem itself. One of the most common reasons analytics projects fail is not because the modeling is poor, but because the business problem was never clearly defined. Teams may disagree about objectives, success criteria, stakeholders, or expected outcomes. Modern AI tools such as ChatGPT, Gemini, Microsoft Copilot, and Claude can act as analytical thought partners during this early phase. For example, leadership may initially state the objective as reducing appointment reschedules. AI can help refine that objective further by identifying related goals, such as improving technician utilization, reducing scheduling volatility, improving forecasting accuracy, increasing revenue capture, and enhancing customer satisfaction. AI can also assist with stakeholder analysis. Service center managers, scheduling teams, operations leaders, customer experience teams, technicians, and executives may all have different priorities. AI can help identify those perspectives and ensure they are considered during project planning. Risk identification is another area where AI provides value. It can highlight potential data limitations, implementation challenges, governance concerns, and operational dependencies before significant resources are invested. Finally, AI can help define measurable success metrics. Rather than vague objectives, organizations can establish specific targets such as reducing reschedules by 10%, increasing technician utilization by 5%, or improving schedule stability across service centers. In many cases, AI helps organizations think more clearly before development begins, reducing project risk and improving alignment between technical teams and business leaders. Section 12. AI-assisted feature discovery. One of the most powerful ways AI can contribute to predictive analytics is through feature discovery. A feature is simply a variable used by a model to make predictions. The challenge is that analysts do not always know which variables matter most when a project begins. AI can help brainstorm and prioritize candidate features based on industry knowledge, historical patterns, and domain expertise. For example, analysts may initially focus on obvious variables such as appointment, lead time, vehicle age, service type, and prior customer history. AI may suggest additional variables that are less obvious but potentially valuable. These might include reminder, open rates, confirmation behavior, day-of-week effects, weather forecasts, traffic congestion, local events, holiday proximity, customer tenure, service complexity scores, or even historical technician availability patterns. AI can also recommend engineered features rather than just raw variables. Instead of using the number of prior reschedules directly, AI might suggest creating a customer reliability score. Instead of using appointment dates, AI might recommend seasonal indicators or weekend flags. The objective is not to blindly accept every suggestion. Rather, AI helps expand the universe of possibilities so analysts can evaluate and test ideas that might otherwise be overlooked. In many successful predictive analytics projects, some of the most valuable predictors originate from feature engineering ideas discovered during this exploratory phase. Section 13. AI for data quality assessment. Even the most sophisticated model will struggle if the underlying data is poor. This is why data quality assessment is often one of the most important stages of any predictive analytics initiative. AI can help accelerate this process significantly. Rather than manually inspecting thousands or millions of records, AI can identify patterns that indicate potential quality issues. For example, AI can detect missing values, suspicious outliers, duplicate appointments, inconsistent formats, invalid date ranges, unexpected category values, and unusual behavioral patterns. Suppose appointment lead times suddenly contain negative values. AI can flag those records immediately, Suppose customer identifiers appear in multiple formats. AI can highlight the inconsistency. Suppose a service center begins reporting dramatically different behavior than all others. AI can identify the anomaly for further investigation. AI can also generate data quality reports summarizing completeness, consistency, accuracy, and validity metrics. This allows analysts to focus their attention where problems are most likely to affect model performance. In many projects, improving data quality creates greater value than improving model sophistication. Clean, reliable data often leads to more accurate predictions and more trustworthy business decisions. Section 14. AI-assisted modeling strategy. After the business problem has been defined and the data has been assessed, the next question becomes, which modeling approach should we use? AI can help answer that question. Different predictive modeling techniques have different strengths and weaknesses. Some are highly interpretable, others are optimized for predictive accuracy. Some handle large datasets exceptionally well. Others perform better with smaller datasets or specific feature types. AI can review project requirements and recommend appropriate candidate models. For our appointment reschedule example, AI may recommend beginning with logistic regression because it is easy to explain and provides probability estimates. It may also recommend random forest because it can capture nonlinear relationships and complex interactions. Finally, it may recommend XGBoost because of its strong predictive performance on structured business data. AI can explain the trade-offs among these approaches. For example, a model with slightly lower accuracy may be easier to explain to executives. A model with higher accuracy may require more technical expertise to maintain. Rather than replacing the judgment of data scientists, AI helps accelerate the evaluation process and provides a structured framework for comparing alternatives. The result is a more informed and efficient modeling strategy. Section 15. Python Workflow Overview. Python serves as the analytical engine behind our predictive analytics workflow. It provides the tools necessary to collect data, clean it, analyze it, engineer features, build models, evaluate performance, generate predictions, and communicate results. Several libraries play important roles throughout this process. Pandas provides powerful data manipulation capabilities. NumPy supports numerical computation and mathematical operations. Scikit-learn offers a wide range of machine learning tools and modeling algorithms. XGBoost provides advanced gradient boosting capabilities for high-performance prediction. Matplotlib and Seaborn help visualize patterns, trends, distributions, and model results. Together, these libraries form a complete ecosystem capable of supporting enterprise-level predictive analytics projects. One of Python's greatest strengths is integration. Data can flow seamlessly from ingestion through deployment while remaining within a consistent analytical environment. This enables organizations to build scalable, repeatable workflows that support both experimentation and production operations. In our automotive service example, Python becomes the foundation upon which the entire predictive analytics solution is built. Section 16. Data ingestion. The first technical step in the workflow is data ingestion. Data ingestion simply refers to loading data into the analytical environment so it can be processed and analyzed. Organizations store appointment data in many different locations. Some use relational databases, others use cloud platforms, spreadsheets, enterprise data warehouses, or operational systems. Python provides tools for connecting to all of these sources. In our example, appointment records might originate from scheduling systems, customer databases, vehicle service systems, weather providers, and communication platforms. These sources are combined into a unified data set that captures relevant information about appointments, customers, vehicles, and outcomes. Data ingestion may sound straightforward, but it is a critical stage of the process. If data is incomplete, delayed, or incorrectly integrated, every subsequent analytical step will be affected. For this reason, organizations often invest heavily in creating reliable and automated ingestion pipelines. Once the data has been successfully loaded into Python, analysts can begin preparing it for modeling. Section 17. Data cleaning. Real-world data is rarely perfect. Missing values, duplicate records, inconsistent formats, invalid entries, and other quality issues are common in nearly every operational data set. Before modeling begins, these issues must be addressed. Data cleaning involves identifying and correcting problems that could distort analysis or reduce model performance. Missing values may need to be imputed or handled appropriately. Duplicate appointments may need to be removed. Date formats may require standardization. Categorical values may need normalization. Business rules may need to be applied to identify invalid records. Consider an example where appointment lead time is recorded as text in some records and as numbers in others. Without correction, the model may misinterpret the data. Similarly, duplicate appointment records can artificially inflate certain behaviors and create misleading patterns. The objective of data cleaning is not perfection. The objective is reliability. By improving consistency and quality before modeling begins, organizations increase the likelihood of producing accurate, trustworthy, and actionable predictions. Section 18. Feature engineering. Feature engineering is often where predictive analytics projects are won or lost. Raw data rarely captures business reality perfectly. Analysts frequently need to transform that raw information into variables that better represent underlying behavior. For example, instead of using the number of prior reschedules directly, we might create a customer reliability score. Instead of using individual appointment dates, we might create seasonal indicators or day-of-week variables. Instead of simply tracking service type, we might create a service complexity score. These engineered features often contain stronger predictive signals than the original data. Feature engineering also allows organizations to incorporate domain expertise into the model. A service operations leader may know that customers who repeatedly reschedule appointments behave differently than first-time customers. A scheduling manager may know that long lead times create greater opportunities for plans to change. Feature engineering converts those insights into measurable variables. In many predictive analytics projects, feature engineering contributes more to performance improvements than changing algorithms. Well-designed features help models understand the business problem more effectively and often lead to significantly better predictions. Section 19. Exploratory data analysis. Before building predictive models, analysts need to understand the data. This is the purpose of exploratory data analysis, commonly known as EDA. EDA involves examining patterns, distributions, relationships, and anomalies within the dataset. For example, analysts may calculate overall reschedule rates and compare them across customer groups. They may investigate how lead time influences behavior. They may examine service types, weather conditions, customer segments, or seasonal trends. Visualization plays an important role in this process. Histograms help reveal distributions. Correlation matrices identify relationships between variables. Heat maps highlight patterns across locations or time periods. Trend charts reveal changes over time. EDA helps answer critical questions. Which variables appear most important? Which customer groups exhibit elevated risk? Are there unusual patterns that require investigation? Are there potential data quality issues that were previously overlooked? The goal is not to build models yet. The goal is to develop a deeper understanding of the problem and identify opportunities that can improve model performance and business value. Section 20. Train test split. Before evaluating any predictive model, we need a reliable method for measuring performance. This is where the train test split becomes important. Historical data is divided into two groups. The training dataset is used to teach the model. The testing dataset is used to evaluate the model on records it has never seen before. This separation helps prevent overly optimistic performance estimates. Without a test dataset, a model might simply memorize historical examples rather than learn generalizable patterns. A train test split allows us to simulate future predictions by asking the model to evaluate unseen data. For example, we might allocate 75% of records to training and 25% to testing. The model learns from the larger training set and is then challenged to make predictions on the testing set. If performance remains strong on unseen data, we gain confidence that the model may perform well in real-world operations. This step is fundamental because accurate evaluation is impossible without an objective testing framework. Before any model is trusted, it must first prove itself on data it has never encountered before. Section 21. Logistic Regression. Logistic regression is often the first predictive model analysts build, and for good reason. Despite its name, logistic regression is actually a classification technique that estimates probabilities. In our case, it estimates the probability that an appointment will be rescheduled. The model examines relationships between predictor variables and historical outcomes. Variables such as appointment lead time, prior reschedules, customer reliability, reminder confirmations, weather conditions, and service complexity all contribute to the final probability estimate. One of the major advantages of logistic regression is interpretability. Analysts can often explain why the model reached a particular conclusion and how individual variables influence risk. For example, the model may determine that customers with multiple prior reschedules are more likely to reschedule again. It may also discover that confirmed reminders reduce risk or that longer lead times increase the likelihood of schedule changes. Executives often appreciate logistic regression because it provides a strong balance between simplicity, transparency, and effectiveness. Although more advanced models frequently outperform it in predictive accuracy, logistic regression remains an excellent starting point and a valuable benchmark against which more sophisticated approaches can be compared. In many organizations, logistic regression serves as the first step toward a broader predictive analytics strategy. Section 22. Random Forest. Random forest extends predictive modeling by combining the output of many decision trees. Instead of relying on a single prediction path, random forest creates numerous trees, using different subsets of data and features. Each tree generates its own prediction, and the forest combines those predictions into a final result. This ensemble approach often captures complex customer behavior patterns that may be difficult for simpler models to identify. For example, a single decision tree might focus heavily on appointment lead time. Another might focus on reminder engagement. A third might emphasize prior customer behavior. Random forest combines these perspectives into a more balanced prediction. This approach also helps reduce sensitivity to unusual records and random fluctuations in the data. From a business perspective, random forest can be viewed as a committee of experts, evaluating the appointment from multiple angles before making a recommendation. The result is often higher predictive accuracy and improved robustness compared to simpler models. Random forest also provides feature importance metrics, helping organizations understand which variables contribute most strongly to appointment reschedule risk. This combination of predictive power and interpretability makes random forest one of the most widely used machine learning techniques in operational analytics. Section 23. XGBoost. XGBoost is one of the most powerful predictive modeling techniques available today. The name stands for Extreme Gradient Boosting, and it has become one of the most popular algorithms in competitive analytics and enterprise machine learning. Unlike random forest, which builds many trees independently, XGBoost builds trees sequentially. Each new tree focuses on correcting mistakes made by previous trees. This continuous learning process allows the model to identify subtle relationships and complex interactions within the data. For example, XGBoost may discover that appointment lead time only becomes important when combined with certain customer behaviors. It may identify combinations of weather conditions, service complexity, and reminder engagement that collectively influence reschedule risk. These types of patterns are often difficult for humans to detect manually. XGBoost also includes mechanisms that help reduce overfitting and improve generalization to new data. In many business applications involving structured operational data, XGBoost frequently delivers the strongest predictive performance among commonly used algorithms. For our automotive service example, XGBoost may ultimately become the preferred production model because of its ability to generate highly accurate probability estimates while handling large datasets efficiently. The trade-off is increased complexity. However, modern AI tools can help explain and interpret XGBoost outputs in business-friendly language. Section 24. Model Evaluation. No predictive model should ever be trusted without rigorous evaluation. A model may appear impressive during development, but unless its performance is carefully measured, organizations have no way of knowing whether the predictions are truly useful. Several evaluation metrics help assess model effectiveness. Accuracy measures the percentage of predictions that are correct overall. Precision measures how often high-risk predictions are actually correct. Recall measures how effectively the model identifies true high-risk appointments. AUC and ROC curves evaluate how well the model distinguishes between appointments that are likely to be rescheduled and those that are likely to remain scheduled. Confusion matrices provide a detailed breakdown of prediction outcomes, showing true positives, true negatives, and false negatives. Each metric provides a different perspective. For example, a model may achieve high accuracy simply because most appointments are not rescheduled. However, if it fails to identify truly high-risk appointments, its operational value may be limited. The goal is not simply statistical performance. The goal is business usefulness. Organizations must evaluate models based on their ability to support decisions, improve planning, and generate measurable operational outcomes. A well-evaluated model creates confidence. A poorly evaluated model creates risk. Section 25. Feature importance. One of the most valuable outputs of predictive analytics is understanding why predictions occur. Feature importance analysis helps answer that question. Rather than simply generating risk scores, models can reveal which variables contribute most strongly to appointment reschedule behavior. For example, previous reschedules may emerge as the strongest predictor. Reminder confirmations may indicate customer commitment and therefore reduce risk. Lead time may reveal that customers who schedule far in advance are more likely to change plans. Weather conditions may influence attendance during certain seasons or geographic regions. Customer engagement patterns may reveal which communication strategies are most effective. Feature importance transforms predictive analytics into a business learning tool. Instead of asking only which appointments are at risk, organizations can begin asking why those appointments are at risk. These insights support process improvements, customer communication strategies, scheduling policies, and operational planning initiatives. In many cases, the business insights generated by feature importance analysis become just as valuable as the predictions themselves. Understanding drivers of behavior often enables organizations to address root causes rather than merely reacting to symptoms. Section 26. AI-assisted Python development. AI tools are changing how analytics solutions are developed. Rather than starting every project from a blank screen, analysts can use AI to accelerate coding, reduce development time, and improve productivity. For example, an analyst may ask AI to generate code for data ingestion, missing value handling, feature engineering, model training, or evaluation metrics. AI can provide working examples, suggest best practices, and help structure complex workflows. This allows analysts to spend less time writing boilerplate code and more time focusing on business problems. AI can also help document code, explain unfamiliar functions, generate visualization examples, and recommend workflow improvements. Importantly, AI does not replace technical expertise. Analysts still need to validate results, verify logic, and ensure the generated code aligns with business requirements. However, AI dramatically accelerates the development process by reducing repetitive tasks and providing rapid access to technical knowledge. For many organizations, AI-assisted development is becoming a significant competitive advantage because it allows teams to move from concept to implementation much more quickly than traditional approaches. Section 27. AI for debugging and optimization. Even experienced analysts encounter problems during development. Code may fail unexpectedly. Data pipelines may break. Models may perform poorly. Unexpected errors may appear during deployment. AI can serve as an effective troubleshooting assistant throughout this process by reviewing error messages, workflows, code snippets, and model outputs. AI can often identify likely causes and suggest potential fixes. For example, AI may detect data leakage issues, incorrect feature encoding, class imbalance problems, inefficient code structures, or evaluation mistakes. AI can also recommend performance improvements. It may suggest alternative algorithms, hyperparameter tuning strategies, feature engineering enhancements, or workflow optimizations. For example, if model training is taking too long, AI may recommend more efficient approaches. If predictive performance is weak, AI may identify opportunities to improve data quality or create more informative features. The result is a faster and more efficient development cycle. Rather than spending hours diagnosing problems manually, teams can leverage AI to accelerate troubleshooting and focus attention on high-value analytical work. This significantly reduces development friction and increases productivity across the entire project lifecycle. Section 28. AI-assisted interpretation. Building an accurate model is only part of the challenge. Organizations must also understand what the model is telling them. This is where AI-assisted interpretation becomes particularly valuable. Modern predictive models can generate enormous amounts of information. Feature importance rankings, performance metrics, probability distributions, operational forecasts, and model explanations can quickly become overwhelming. AI helps translate technical outputs into business language. For example, rather than simply reporting that appointment lead time contributes 13% of model importance, AI can explain what that means operationally. It may identify patterns indicating that customers scheduling further into the future are more likely to change plans. Rather than reporting a statistical correlation, AI can translate that relationship into practical recommendations. AI can also summarize model results for different audiences. Data scientists may require technical detail. Operations managers may prefer actionable insights. Executives may need concise summaries focused on business impact. This ability to transform analytical complexity into understandable narratives dramatically increases adoption and decision-making effectiveness. Ultimately, predictive analytics creates value only when people understand and act upon the results. Section 29. From prediction to action. Predictions become valuable only when they influence decisions. Our model generates probability scores for every appointment. Customer A has a 12% probability of rescheduling. Customer B has a 43% probability. Customer C has an 81% probability. Although all three customers may ultimately keep their appointments, their risk levels differ significantly. Customer A represents relatively low risk. Standard communication procedures may be sufficient. Customer B represents moderate risk. Additional reminders or personalized outreach may be appropriate. Customer C represents high risk. Proactive intervention may be justified to reduce the likelihood of disruption. Probability scores help organizations prioritize limited resources. Instead of treating every appointment equally, teams can focus attention where it is most likely to produce value. This concept scales well across large organizations. Rather than evaluating thousands of appointments manually, managers can quickly identify high-risk segments and allocate resources strategically. The objective is not to predict every outcome perfectly. The objective is to use risk information to make better operational decisions. Section 30. High-risk appointment management. High-risk appointments create opportunities for proactive intervention. When a model identifies elevated reschedule risk, organizations can take action before disruption occurs. One common strategy is proactive outreach. A personalized phone call, email, or text message may help confirm the customer's intentions and identify potential scheduling concerns. Additional reminders can also improve appointment commitment. Organizations may send follow-up notifications several days before service, increasing the likelihood that customers maintain their appointments. Schedule adjustments represent another possible intervention. If a customer appears likely to reschedule, managers may proactively offer alternative appointment options that better match the customer's needs. Some organizations also use waitlists to fill potential gaps created by high-risk appointments. The specific intervention strategy depends on operational objectives and available resources. What matters most is that the organization has visibility into risk before disruption occurs. Predictive analytics transforms uncertainty into actionable information, allowing teams to respond proactively rather than reactively. This shift often leads to better utilization, improved customer experience, and more stable operations. Section 31. Capacity planning and technician utilization. Individual appointment predictions are useful, but the real strategic value emerges when probability scores are aggregated across the entire organization. Rather than focusing on a single customer, leadership can evaluate thousands of appointments simultaneously and identify broader operational trends. For example, if a particular service center shows an unusually high concentration of elevated reschedule risk, managers can prepare accordingly. Technician schedules can be adjusted. Service bays can be reallocated. Additional customer outreach can be planned. Alternative work can be scheduled to minimize idle time. Probability scores also support workforce planning. If predictive models suggest that appointment volatility will increase during a particular week or seasons, staffing plans can be adjusted proactively. Conversely, if schedules appear highly stable, managers may have greater confidence in current staffing levels. Technician utilization is one of the most important operational metrics in automotive service organizations. Underutilized technicians represent lost productivity, while overloaded technicians can create delays and customer dissatisfaction. Predictive analytics helps balance these competing risks. By forecasting appointment stability before disruption occurs, organizations gain greater control over labor planning, workload distribution, and service center efficiency. Instead of reacting to scheduling changes as they happen, managers can prepare for them in advance. That shift from reaction to anticipation is one of the most valuable outcomes predictive analytics can provide. Section 32. Operational dashboards. Most executives and managers will never interact directly with machine learning models. Instead, they consume predictions through dashboards and decision support systems. Operational dashboards transform complex analytical outputs into clear, actionable information. For example, a dashboard might display high-risk appointments scheduled for the coming week, ranked by predicted reschedule probability. Managers may also view service center risk levels, technician utilization forecasts, expected reschedule volumes, customer communication metrics, and operational trends. Heat maps can highlight regions experiencing elevated scheduling volatility. Forecast charts can estimate future disruption levels. Alert systems can identify service centers requiring immediate attention. The goal is not simply to display data. The goal is to support decision-making. Well-designed dashboards help managers focus on what matters most without requiring them to understand every technical detail behind the predictive model. This is where analytics becomes operationalized. Predictions move from the data science environment into the daily workflow of managers, schedulers, and executives. When that happens, predictive analytics begins creating measurable business value. Section 33. AI-powered executive reporting. After predictive models generate results, organizations face another challenge: communicating those results effectively. Executives are often responsible for making decisions across multiple business functions. They typically do not have time to review detailed technical outputs, model diagnostics, or hundreds of pages of analytical reports. AI can help bridge that gap. Using model outputs, AI can automatically generate executive summaries that highlight key findings, emerging risks, performance trends, and recommended actions. For example, AI might identify that appointment reschedule risk has increased in specific regions due to seasonal factors. It may summarize which customer segments exhibit the highest risk levels. It may explain how projected reschedules could influence technician utilization, capacity planning, and revenue forecasts. Rather than requiring analysts to manually prepare every report, AI can generate first drafts, executive briefings, management summaries, and presentation content automatically. This dramatically reduces reporting effort while improving communication speed. More importantly, it ensures that analytical insights reach decision-makers in a format that supports timely action. Analytics creates value only when insights influence decisions, and effective reporting is a critical part of that process. Section 34. AI-powered recommendations. Predictions tell us what might happen. Recommendations tell us what we should do about it. This is where AI can provide tremendous value after model development. Using probability scores, operational constraints, and business objectives, AI can generate recommended actions designed to reduce risk and improve outcomes. For example, AI may recommend additional customer outreach for high-risk appointments. It may suggest technician schedule adjustments to accommodate expected volatility. It may recommend activating waitlists, redistributing workloads, or reallocating resources across service centers. AI can also prioritize actions based on expected impact. Rather than overwhelming managers with dozens of suggestions, it can identify the interventions most likely to produce meaningful operational improvements. In many ways, recommendations represent the final step in the analytics value chain. Data becomes information. Information becomes insight. Insight becomes action, and action creates business value. When organizations combine predictive analytics with AI-generated recommendations, they move beyond forecasting and begin influencing future outcomes directly. Section 35. Prediction versus K-means, classification, regression, PCA, and TOPSIS. Predictive analytics is often confused with other analytical techniques because many of them use similar data and tools. However, each technique serves a different purpose. K-means clustering groups similar records together. It helps identify customer segments or operational patterns, but does not directly predict future behavior. Classification predicts categories. In fact, our appointment reschedule model can be viewed as a classification model because it predicts whether an appointment is likely to be rescheduled or not. However, in business settings, the focus is often on the probability score rather than the category itself. Regression predicts continuous numerical values. For example, regression might estimate repair duration or future revenue rather than appointment reschedule risk. Principal component analysis, or PCA, reduces dimensionality. It simplifies complex data sets by combining related variables into a smaller number of components. PCA helps with understanding data structure, but does not predict customer behavior directly. TOPSIS is a decision ranking technique. It evaluates alternatives and ranks them according to multiple criteria. It helps prioritize choices, but does not estimate future probabilities. Appointment reschedule prediction focuses on estimating future risk. The objective is to understand the likelihood of future customer behavior so organizations can take proactive action before disruption occurs. Although these techniques can complement one another, they solve fundamentally different business problems. Section 36. The boardroom story. The most important lesson in this entire video is that the real business story is not about algorithms. Executives rarely ask whether a model used logistic regression, random forest, or XGBoost. They rarely ask how many trees were included in the model or how hyperparameters were configured. Instead, executives ask different questions. Did technician utilization improve? Did scheduling volatility decrease? Did customer satisfaction increase? Did profitability improve? Did forecasting become more accurate? Did operational efficiency improve? Those are the questions that matter in the boardroom. Predictive analytics becomes valuable when technical outputs are translated into business outcomes. In our automotive service example, the story is simple. The organization identified appointment risk earlier. Managers took proactive action. Scheduling disruptions decreased. Technician productivity improved. Customers experienced more reliable service. Financial performance benefited as a result. That is the story executives care about. The algorithms make the outcome possible, but the outcome itself is what creates value. Successful analytics leaders understand how to connect technical insights to strategic business objectives. Section 37. Common mistakes and limitations. Predictive analytics is powerful, but it is not magic. One of the most common mistakes organizations make is assuming that a model can predict the future with certainty. Models estimate probabilities, not guarantees. Another common mistake involves poor data quality. Incomplete, inaccurate, or inconsistent data can significantly reduce predictive performance. Organizations may also struggle with changing behavior patterns. Customers evolve. Markets change. Economic conditions shift. Operational processes improve. Models must adapt to these changes over time. Bias can also become a concern if historical data does not accurately represent future conditions. Even highly accurate models can fail if operational teams do not act on the predictions. A prediction that sits unused in a dashboard creates little value. Organizations must establish processes that convert predictions into decisions and decisions into action. Finally, predictive models require ongoing monitoring. Performance should be measured continuously. Data quality should be reviewed regularly. Models should be retrained when necessary. The most successful organizations view predictive analytics as a living capability rather than a one-time project. Section 38. Executive cheat sheet and call to action. Let's conclude with an executive summary. If your organization experiences appointment volatility, customer no-shows, scheduling disruption, technician utilization challenges, or forecasting uncertainty, predictive analytics may offer significant value. Start with historical data. Understand the business problem clearly. Identify the operational decisions that predictions will support. Use AI to accelerate planning, feature discovery, coding, interpretation, reporting, and recommendation generation. Use Python to build scalable and repeatable analytical workflows. Evaluate models carefully and focus on measurable business outcomes. Most importantly, remember that predictive analytics is not about technology for technology's sake. The goal is not to build sophisticated models. The goal is to make better decisions. In our automotive service example, predictive analytics enabled leadership to identify appointment risk before disruption occurred, improve operational planning, support technician utilization, enhance customer experience, and increase organizational efficiency. That is the true value of predictive analytics. Appendix A. Logistic Regression, Executive Version. Logistic regression is one of the most widely used predictive analytics techniques in business. Although the mathematics behind it can become complex, the executive-level concept is relatively straightforward. The model examines historical data and identifies relationships between predictor variables and outcomes. Those relationships are then converted into a probability score between 0 and 100%. In our appointment reschedule example, the model evaluates factors such as customer history, reminder engagement, appointment lead time, service type, and other variables. Based on those factors, it estimates the likelihood that an upcoming appointment will be rescheduled. One reason logistic regression remains popular is its transparency. Analysts can often explain why a prediction was generated and which variables influenced the result. This makes the model easier to communicate to business stakeholders and executives. Although more advanced techniques sometimes deliver higher accuracy, logistic regression often provides an excellent balance between interpretability, simplicity, and predictive value. For many organizations, it serves as the starting point for predictive analytics initiatives. Appendix B. Random Forest, Executive Version. Random forest can be thought of as a committee of experts making a prediction together. Instead of relying on a single decision tree, the algorithm builds many decision trees using different portions of the data and different combinations of variables. Each tree independently evaluates the appointment and generates its own prediction. The forest then combines those individual predictions into a final result. This approach often produces more reliable predictions because it reduces sensitivity to unusual records and random variation. In our automotive service example, some trees may focus heavily on customer history. Others may emphasize reminder engagement, service complexity, weather conditions, or appointment timing. By combining these perspectives, the model often captures patterns that individual trees might miss. Random forest is particularly valuable when customer behavior is influenced by many interacting factors. It provides strong predictive performance while still offering useful insights regarding feature importance and business drivers. For executives, random forest can be viewed as a structured process for combining multiple expert opinions into a single recommendation. Appendix C. XGBoost, Executive Version. XGBoost is one of the most powerful predictive modeling techniques available for structured business data. Unlike random forest, which builds many trees independently, XGBoost builds trees sequentially. Each new tree focuses specifically on correcting mistakes made by previous trees. Over time, the model becomes increasingly effective at identifying subtle relationships and complex patterns. For example, it may discover combinations of customer behavior, appointment timing, reminder engagement, weather conditions, and service characteristics that collectively influence reschedule risk. These patterns are often difficult for humans to identify manually. One reason XGBoost is so popular is its ability to achieve very high predictive accuracy while handling large datasets efficiently. In many business applications, it consistently ranks among the best-performing machine learning algorithms. Although the underlying mathematics can be sophisticated, the executive takeaway is simple. XGBoost learns from previous mistakes and continuously improves its ability to estimate future outcomes. That capability often makes it a strong candidate for production deployment in enterprise predictive analytics environments. Appendix D. Probability Scoring, Executive Version. Probability scoring is the mechanism that transforms model predictions into actionable business information. Rather than providing a simple yes or no answer, predictive models generate a probability estimate. For example, one appointment may have a 12% reschedule probability. Another may have a 43% probability. A third may have an 81% probability. These scores help organizations prioritize attention and resources. Low-risk appointments may require no additional action. Moderate-risk appointments may justify enhanced monitoring or reminder campaigns. High-risk appointments may trigger proactive outreach, schedule adjustments, or contingency planning. The objective is not to eliminate uncertainty completely. The objective is to manage uncertainty more effectively. Probability scores allow organizations to focus effort where it is most likely to produce value. At scale, this can improve technician utilization, reduce scheduling disruption, improve customer experience, and support better strategic planning. In many predictive analytics initiatives, probability scoring serves as the critical bridge between analytical insight and operational action. A call to action. Thank you for spending time with us today. If there is one key takeaway from this discussion, it is that predictive analytics is not really about algorithms, machine learning models, or programming languages. It is about making better decisions before problems occur. Whether you are a project manager, program manager, portfolio manager, business analyst, data scientist, operations leader, executive, or simply someone interested in the practical application of AI, the ability to anticipate future behavior is becoming one of the most valuable skills in modern organizations. The automotive appointment reschedule example we explored today is only one application. The same principles can be used to predict customer churn, employee turnover, project delays, equipment failures, warranty claims, inventory shortages, demand fluctuations, and countless other business challenges. The combination of AI and Python has dramatically lowered the barrier to entry. Organizations no longer need massive teams or enormous budgets to begin building predictive solutions. With the right business problem, quality data, and a structured analytical approach, meaningful results are more accessible than ever before. If you found value in this video, please consider liking, subscribing, and sharing it with colleagues who are interested in AI, analytics, operational excellence, and executive decision-making. And most importantly, don't just learn these concepts. Apply them. Identify a business problem in your own organization. Gather the data. Use AI to accelerate your thinking. Use Python to build the solution. Measure the results. Then tell the business story behind the numbers. Because the organizations that learn to predict disruption before it happens will often outperform those that simply react after it occurs. Thank you for watching. This is SRR Strategic Intelligence. We'll see you in the next video.